Hi guys, we're going to go ahead and start our first lesson here in our new our new platform Canvas. And so hopefully you've been able to print out the data that you have. If not, then the lesson. So then some of these things you could just look at on the side and stuff. But you really will do better if you have been able to um, print out the packet that goes along with this unit's review. Okay, so here we go. We are going to start with stuff about proportions, inference about proportions. Okay, broke it into proportions and means. And I'm going to just remind you about this whole population versus sampling distribution. Remember those drop down samples and what the notation is. Remember, it's important that we know the notation. We're really paying attention between population and sampling distribution. Okay, this first lesson, because I'm going to try and keep these shorts, is about the 1 and 2 proportions intervals, z intervals, and then how we're writing their conclusions. Okay, so here we go. All right, first, I want to remind you that with proportions, because this is categorical data, there actually is no shape for the population. Okay, but it's when you take a sample. So let's see, I have the population proportion, of course, okay, and is the P, and then it doesn't have a standard deviation because there is no shape for this, okay, because it's just categorical. I could rearrange those bars however I want, okay, so no variability there. Now, then I take samples. Okay, and if they are large enough, then we know that when we take that sample p hat, we're collecting the true proportion of blue M&Ms. Sampling variability happens, and you're going to get different samples than me because of sampling variability. So you get a different proportion of blue in your sample than mine. So we end up with this distribution that's approximately normal. Okay, and if we were asked to describe the distribution, then we would want to talk about that shape, outlier, center, and spread. Okay, and so, we would say things about how it's going to be unimoto and symmetric. You want to say where it will be centered. And so you would expect the center of all of those sample proportions, the center of all those p hats to be where the population p is. If they say it's 24% blue M&Ms, then you think on average people's p hats will be clustered around 24%. Okay? But then once we have this distribution here, we do have now a standard deviation. So then that's one that you compute. And so that spread, if you remember, is that P times 1 minus P over N. Okay, and if you have true P, you're using that. Only if you don't have that, you're using your P hat. Okay, so there's that idea of those sampling distributions. So now let's talk about this idea. So the 1 proportion z intervals. Okay, let's remember what an interval does for us. Okay, that interval is that range of plausible values that allows us to estimate, and we're estimating like the true proportion of all blue M&Ms that the Mars company puts out from our samples. Okay, from our sample proportion. And so here is what is on the formula chart. So that is the very generic way to say this, okay? But then here is what you have to come up with based on that, okay? So here is your p hat you would get. That's your sample. And then here's your critical value, okay? Remember, you would do the inverse norm of 1 tail for that. And then here is that computing of that standard deviation of the p hats. So in this case, since we don't have p, we're using p hat, and that makes it the error, the standard error of that statistic. Okay, so now with that being said, let's think about what's happening here. Here's a picture of our intervals. Okay, so we have that p hat. It also is using the language point estimate. Okay, point estimate. They might say, your point estimate is such and such. Well, that's your p hat that you got. And so that's always right in the middle. So remember, your p hat is always in the center, exactly in the center of that interval. Okay, and then you have your margin of error up to the upper bound and your margin of error down to the lower bound. And remember that this here, that in, because we would use that later in some computing, that this critical value, okay, this critical value times this standard deviation, that is the part that is that margin of error. This is the part that makes that whisker there and there. So those are the same size, okay? All right. So of course, you know, to get your upper bound, you do your p hat plus the margin of error, and to get the lower, it's p hat minus. Okay. Now, review, computing that critical value. Remember that critical value, you need to find the critical value. While you may have the confidence level, they may say, hey, be 95% confident, okay? But that's, your critical value isn't 0.95. No, no, no. You need to find the critical value while you may have this confidence level. That confidence level is what's in the middle. So 95% is what's in the middle. You inverse norm one tail. Inverse norm of one tail. So if we have 0.025 and a tail, I'm going to inverse norm that, and from it, I will then get my negative z, my negative critical value. And you know, because of symmetry, that the positive one is going to be that same distance from the middle. Okay. Now, technically, I have had you do those by hand. And it is important that you keep track of the formula and everything, and that you understand what's going on there. Okay? But honestly, at this point, you can just do your computing for the interval this way if you wanted to, where you are doing your one proportion z interval. This is the way the calculator commands would go. One proportion z interval. The thing you have to watch is that if, suppose they said you had 13% of 27, you took a sample and 13% of 27 items were blue M&Ms. Okay? Okay. Well, this here is a whole number of items. So if you take 13% of your 27 M&Ms, I'm pretty sure that's not a whole number. Then you need to make sure, though, that you round it appropriately and you put that whole number in there, okay? Within, of course, being your sample size and then your confidence level. So, quick interpretations. Notice I have here the interval interpretation versus level interpretation. And so we'll talk about that here in a second. But your panic model does this first conclusion where it says, I am 90% confident that the true proportion of blue M&Ms produced by the Mars Company is between 16% and 26%. Okay? So that's how you interpret your interval. But confidence level doesn't have those interval numbers in there. Okay? And especially this year in particular, since the AP test is going to be more about interpretations, I could totally see you having, it's important that you understand how to do that in context. So I'm about 90% of all 90% confidence intervals. Remember that if we drew a whole lot of those intervals, if we had a whole lot of intervals on the board, remember when we've done that? A whole bunch of people made all their intervals, off of their p hats, okay? then about 90% of all of these 90% intervals will contain that true proportion of blue M&Ms that the Mars Candy Company makes. Okay? All right. So really important you understand the language between those two. Remember Smelly Cat song? How many, and what size interval? How many contain the true P? About 90% of all the 90% confidence intervals, that's the size. And what size interval? How many contain the true P? All right. Now, let's go to two proportion intervals. This, again, right here is on the formula chart, okay? They also do show this on the formula chart in another section, so they don't actually put this whole thing on there. So when you're doing the difference between the two proportions, your statistic is that difference between your two sample proportions, okay? There's your critical value. And then they do also have this formula for the standard deviation for two proportions on the formula chart. Okay. And so once again, that section right here is your margin of error. Okay. We typically don't do those by hand. I've shown you this formula because in the past, when we have multiple choice questions, then a lot of times they'll plug in numbers. And so maybe they're going to do that. They could say, they can plug those numbers in and then ask you to say if there's an error with it or whatever. But plug in those numbers and see if it's going to be computed correctly. But calculator is typically how we do that, to where we're putting it into the two proportion Z interval. And once again, same comment. This thing right here, your X value here and your X value, make sure those are whole numbers, not percents. So if they say 13% of 27 in this sample are such and such, figure it out as a whole number. Okay. So now, here was the interesting problems when we would have the difference between two proportions and when we did the interval, okay? This is when you need to, that difference, you have to define the way that difference looks, okay? So see, I defined that I was doing, in this case, the proportion of Alito students who own an Apple iPhone X minus the proportion of Alito students who own an Apple Watch, okay? And so I'm interested that I got this number here that both of these are negative, okay? So that's of interest to me that they're both negative. With them both being negative, then I can tell in both cases this iPhone X proportion is a smaller proportion, okay? So that's how I interpret that interval. I'm 95% confident that the difference in those proportion of AHS students who own an Apple iPhone X and a Apple Watch is between 3% and 12% lower for the proportion who own an Apple iPhone X. Okay? And here's the one about 0. 0 is not in there. It's completely below the 0 mark. Okay? So it is showing a significant difference. So since 0 is not in there, then I have evidence that there is a significant difference between those two proportions. Here's an example here, and what you're going to notice between the Alito and Willow Park Sonics and the proportion of their drinks sold that are Route 44, okay? So I'm, once again, defining the way I'm doing the subtraction. I'm going to take the proportion at Alito minus the proportion at Willow Park, okay? And then notice, one of the problems is one of the answers proportions is negative. One of the proportions is positive. So what that tells me is the Alito Sonic could be lower or it could be higher. Okay? So here's how we write that. I am 90% confident that that difference, that true difference between those two proportions in context, the proportion of Sonic drinks sold at Alito that are Route 44 is between 3.4% lower up to 5.6% higher. So in both cases, I'm talking about the Elitosonic being 3.4% lower up to 5.6% higher than the proportion of Sonic drinks sold at the Willow Park. Okay? And in this case, zero is in there. Zero is in there. So that's saying that there's not evidence of a significant difference. I don't have a clear indication that one's definitely higher or lower than the other. Okay? All right. And the final item here is, we're going to do the assumptions later. Okay. So that's the end of just the basic video about the items that we covered here with the population sampling distributions reminder and the 1 and 2 proportion intervals and their conclusions. Okay?